We're discussing projectile motion, and we're looking at horizontal range and maximum height. So right now, let's look at an equation for how to find the time that it takes to get to the maximum height for projectile motion. That would be this position here, and that point is half of the range. The entire range is the distance you're going to travel here. Half of the range would be r over 2, and that's your x-coordinate point. And your y-coordinate point we call y sub h. And that y sub h is y because it's the y-coordinate, and h because it's the maximum height. Now the velocity at this point, the y velocity, is 0 meters per second. Because the object, as it travels upward, it's slowing down until it comes to a stop. It comes to a stop at the maximum height. It changes direction and starts to come back down. So when we look at this, we know that there is an initial velocity. That initial velocity we normally call v naught, but it's divided up into two components. The two components are v naught x and v naught y from earlier. Now what we're going to do instead is we're going to look at Vf is equal to Vi minus Gt. This is one of the 5 linear equations. It's the first linear equation that we've modified for free fall motion for an object that's traveling in the upward direction. Now we're going to modify this and look at it in terms of only in the y component directions. The Vf, the final velocity, is going to be Vy. So this will be Vy is equal to the initial velocity is the initial velocity in the y direction, Vy naught. So I think I called it the other day V naught y, so we'll go with that. That is V naught y, and this is just minus Gt. We also showed earlier that theta is here, the 90-degree angle is there, and sine theta is equal to opposite over hypotenuse, so V naught y divided by V naught. V naught y is equal to V naught sine theta. We can substitute for V naught y here. So Vy is equal to V naught sine theta minus Gt. And now we can look at this and solve for time. Vy is equal to 0. So we make that substitution. 0 is equal to V naught sine theta minus Gt. Subtract V naught sine theta the other side. So negative V naught sine theta is equal to negative Gt. Divide the negative signs out. So divide by negative 1. The negatives cancel. You're left with V naught sine theta is equal to Gt. Divide everything through by gravity. And you're left with time is equal to V naught sine theta divided by G. This is the final equation to solve for the time that it takes to reach the maximum point. If you wanted to get to this point, you would multiply that time by 2. So you would have this, the total time, capital T, is equal to 2 V naught sine theta divided by G.